All right, let's get rolling. So I want to say hi to everyone. My name is Aneesh. I am the CTO at Quilt Data, and we integrate all your data sources so that everyone is on the same page and you can make smart decisions faster based on all of your data in S3. And I'd like to introduce my friend, Stephen Kuenzli. He happens to be a Phoenician, so in the Phoenix area like myself. And we're both tech folks and stay in touch. And we went on a hike and he started really talking my ear off about RBAC, ABAC, and KMS, resource boundaries with KMS. And as Quilt CTO, I get to work with a lot of companies, Arbor, Vir Biotechnologies, Stemson Therapeutics, Celsius Therapeutics, and I feel like security being so close to S3 especially is a really urgent concern in life sciences, particularly because there's so much cross-functional work, number one. And number two, a lot of times you don't have a lot of IT or DevOps horsepower to be in there and like finally slicing permissions. So the entire purpose of this webinar is really for everybody that's here. It is being recorded and that's for your benefit. I'll be happy to share the recording with you when it is ready. And we also have a little Q&A feature. So please pause us, raise your hand. This webinar is for you. It's not for our benefit. We hope it'll be super interactive and we'll be looking forward to your questions. Any procedural questions? I'm going to read Stephen's bio in just a second and we're going to jump right in. Any procedural questions before we get rolling? Okay, great. So Stephen is a security expert. He is co-founder at K9, and he is also the author of Effective IAM, which you can find on the web. And it's how we both got connected. And you'll hear from both of us as the webinar proceeds. And again, designed to be very practical, things you can take home today. And so I would love, Stephen, go ahead and take it away.
Thanks, Aneesh. And thank you everyone for joining us today. Welcome to Simplify and Secure AWS Data in the life sciences arena. So as Aneesh talked about, we're going to talk about the problems and solutions for managing access for so many people and so many data sources, particularly when the desired access changes frequently. So we're going to discuss overall how to simplify and secure IAM in a scalable way. And we're going to cover 3 different models for using IAM: role-based access control, attribute-based access control, and resource boundaries, and how those work for large teams. We're going to show how to use a resource boundary based on KMS encryption. It will help you quickly secure and audit access to entire data domain. We're going to shine a light on that because it's not as well known or understood as the other models. And then all throughout, we're going to discuss the trade-offs in managing IAM in large organizations with complex access patterns. So with that, let's move along. So I want to start at the top. And every organization has an access management loop. And often we interact with this where like some science or project team needs to work on some data or use a service that they haven't used before. And then someone like a cloud or platform engineer takes a look at what access the requester has and then develops a change to IAM that grants access to the requested resources. And in practice, and I've worked, especially as a consultant leading cloud migrations and like implementing continuous delivery and moving people to the cloud, granting additional access is the most common case in practice. But almost all information security policies also require that IT or some other functionary reviews granted access periodically and revoke unneeded access. Whether you call that trying to implement principle of least privilege or not is a separate matter, but there's always a review process. So, at the bottom, when we get to the bottom of this loop, we're actually supposed to come and analyze the accesses out there, review it for access permissions, and then revoke those access permissions. But I have a question, might be a little colloquial, but like, do you even loop, bro? Like, when was the last time you completed this loop and how long did it take to actually go around this access management loop? Or you might even think of it as an access control loop and pull in all those thoughts from control theory. because we should be executing this whenever we're adding new team members, new projects, as well as periodically. And perhaps more pointedly, when was the last time you verified who has access to your most critical buckets in your org? That's a shockingly difficult question to answer in many cases, in many orgs, like who has access. So, and the trouble with all these buckets is that new buckets pop up all the time as scientists and engineers do their work. In traditional role-based access control, that means cloud engineers have to update security policies to allow access to those named buckets. They typically do from the identity side, a policy attached to the role. And this might be happening a couple of times per week. And we also had a request to lock down all the access to the critical data this quarter, this year, or some other deadline. But what you're really thinking is, can we get out together? Because AWS IAM is hard, and it's consuming a lot of resources. So quick refresher on the general IAM model. So at its core, IAM is about writing security policies that control whether a principal, an IAM user, or a role may act by calling an action like get S3 get object, DynamoDB get item on a resource, a bucket, a DynamoDB table, an EBS volume, etc. Is what we're trying to implement. And IAM gives us tremendous flexibility in how we do that. And now I'd like to introduce Tesler's law of the conservation of complexity, which is that every application has an inherent amount of complexity, like Brooks's inherent versus accidental complexity. This complexity cannot be removed. Instead, you have to deal with it, either in product development, where you're encapsulating this complexity in some sort of tool, or in user interaction, where it bubbles up and an engineer is dealing very complicated. So let's return to our role access control, attribute-based access control, and resource
Quick
boundaries.
thing, Stephen, sorry to interrupt. Your audio is dropping out a little bit. You might want to pause your video. I think you'll get better audio that way.
Sorry about that. Thanks, Aneesh. So what we're going to do is we're going to examine these three models today. And we're examine how well they work with large teams across basic attributes. Usability, how easily cloud engineers can understand the state of the system and modify its behavior, correctly being the key. Scalability, how many security policy and automation modifications are required access to data resources, where fewer is better. Flexibility, how well does the model adapt to changing requirements and dimensions of access control? And then completeness of principal access control. How well does the model control what a principal has access to, or data, from the principal side? And then how well does the model control access to data by principals, and whether it prevents unintended access by over-provisioned principals? And finally, auditability. How easily can you verify your policies do what you think they do? So we're not going to force you to wait for the answer. Here's what we think, how well each of these different IAM models work with large teams. And we can see Tesler's law of the conservation of complexity at work. There's a certain amount of inherent complexity in the access we're trying to manage, and it has to go somewhere. So let's just zoom in on two attributes to begin with: scalability and usability. The scalability of role-based access control, you have to make a lot of policy changes. It's basically one-to-one whenever a principal is added or a data resource is added. Attribute-based access control, it's high. You generally have a few policies, like several, a handful, that may be able to allow access for many principals, like 100 principals, because we're reusing that policy. Similarly, with resource boundaries, and we'll get into this in a bit, there's only a few like a relatively slow growing number of data domains, and we can control access to that data domain with KMS. Now, on the usability side, role-based access control policies are generally pretty simple. They're relatively simple to write and perhaps understand, at least on their own. Whereas attribute-based access control often uses very advanced IAM policy features, and they're difficult to develop and reason about. So at the end, at scale, it's difficult to verify what the net effects of your identity policies actually grant. Once you have, like, especially in a non-trivial AWS account, which is basically everyone's production account, because there are so many interactions between people or between roles and data resources. So, and we're gonna dig into like how you might control that with resource boundaries. So, but the point is that like we can see some things emerging that we're probably gonna have to make some trade-offs here.
So when it says high in flexibility versus brittleness, is that high flexibility?
Yes. Sorry, I removed some parentheses that to make some things fit earlier. And yes, it's flexibility. Flexibility is what we're ranking for here. So role-based access control has more flexibility because you have the opportunity to write an identity policy for every identity. There's no, attempt really, there's no built-in attempt to reuse. And so you can adapt that policy to changing requirements however you need. Whereas it might be more difficult to shoehorn the new requirement into one of your 4 ABAC policies that apply to 100 principles. So quickly, what's RBAC? Role-based access control is what I call like the normal default IAM authorization model, and you generally manage access with the principal and resource elements in primarily identity, but you can also do resource policies. And people, those policies typically get attached to an identity, an IAM user or role. And as time goes on, you often end up resorting to wildcards pretty quickly, because let's take a look at what could be considered a least privilege identity policy granting access to a sensitive data bucket. You name the actual resource. So we're going to allow get object and also to list the bucket, so we can see what data is in the bucket and we can get data out of the bucket. And the bucket that we're allowing access for is the sensitive data bucket. And this is precisely what changes every time you add a bucket. And you can address that perhaps with naming conventions and some well-placed wildcards. But at the end of the day, you have at least, let's say one identity policy for every team. And there's a constant amount of churn and maintenance burden associated with maintaining what the resources being allowed in that resource element section are. Now, on the good side, it does allow access for the intended principal, but because identity policies are generally managed just on the principal side, it doesn't protect data over here from unintended access. And this can occur, unintended access can occur when something like, say, a third-party monitoring tool gives read-only access, which gives that role the ability to call S3 get object on any object in the account, even though like it has no business requirement to do so. So that's what I mean by, in differentiating between controlling access or granting access from principal and resource. RBAC and ABAC, they are primarily focused on the IAM principal side versus the resource side. So RBAC, great for allowing some access from the principal side. So just to quickly summarize, RBAC is kind of the default model. It has the best docs, the best blog posts, or the most blog posts anyway. And it's the basic model and it's relatively simple to understand. On the downside, security policies are perhaps difficult or at least tedious to write in practice in order to implement like a proper, something approximating least privilege. It's difficult to scale to tens of teams and hundreds of resources. And you often end up giving up on your conventions or having to accommodate lots of unusual things and dropping down to using wildcards. And overall, no one understands what their policies do. And this often manifests as overloaded experts and poor security. And so while RBAC is simple, it generally fails to scale to large environments. So what is ABAC? Attribute-based access control is an authorization model built on object attributes, where you describe what your principal and resource are with tags, and then you write policies that grant or deny access when tagged with certain values. So you might build your ABAC model around a tag named resource group, and you might have the value of that. One of the values of that resource group might be moonshot, or it might be apple. And when you implement ABAC, you create identity policies and attach them to IAM roles and users. And then you tag your principals or sessions with resource group equals something. And then you apply a similar set of tags on the resource side. So that sensitive app data bucket might be tagged with resource group equals moonshot. And so a policy, like one of the simplest forms of an ABAC policy is I'm showing right now, this would allow a restricted set of principals to read the data, and they'll be able to do that when this would be an identity policy attached to an IAM user role, and it would allow execution of get object when the S3 object has a tag named resource group, and the value of that tag matches a tag on the principal, the IAM user role, also a resource group. So if they're moonshot on both sides, then the access is allowed. Now, these are, we're getting into like a more of an advanced IAM policy context key and context and policy conditions here. And the good news is this allows access for the intended principal as long as you're trying to like grant access to everything in this resource group to the principal. But it may not protect data from unintended access. Again, if this takes place, this policy in this scenario we're talking about, it's attached on the identity side, on the IAM role or user. So this is allowing some folks access. It doesn't really, unless you put something on the resource side, it doesn't prevent unintended access. And you may also notice that this is using the S3 existing object tag. This is a special tag for doing ABAC, or a special policy context key for doing ABAC with S3, because S3 is special. in the general case. And throughout other parts of AWS, you would typically use a context key called AWS resource tag. If you were limiting access to, say, in particular, like a KMS key or a DynamoDB table. But that's generally how the model works.
Quick thing, Stephen, I wonder if you dilate a little bit on your last bullet on not protecting unintended access. And I guess the naive question is, if your tag sets match, where is it that we're allowing unintended access?
So again, if you have, say, a third-party monitoring service with the AWS managed policy read-only access that allows S3 get object on all buckets, that would be applied directly to that third-party role, not say one of your scientist roles or engineer roles that you have specifically built one of those several 4 or 5 ABAC policies for. So it's kind of like an independent set. So and this is where this is kind of a case where a lot of folks, they think about allowing access. And if you think about that access management loop, the job is often considered done once we've allowed access and people can proceed along with doing their job. And part of information security is about minimizing total risk to our data, which means preventing unintended access so that you can cut off risks from either accidental primarily or malicious access attempts to data. Did that answer your question?
Yeah, very much so. And I'm setting up the distinction between resource boundaries and ABAC, so appreciate that.
Okay.
Great. So I want to talk to you a little bit about ABAC and SSO. So as a general rule, when we're talking about attribute-based access control, we've just seen that the attributes can be placed on the resources directly, but then there's a matchmaking that needs to take place, which was this condition key that we were just looking at. And the question is, where do the user attributes come from? They generally come from SSO. So if you're familiar with how SSO flows like Okta work, you generally get assigned a JavaScript Web Token or JWT from the SSO service. And that token can be opened by an application, and that includes the user's claims. And the claims would exactly be things like tags, departments that the user belongs to, what are the attributes really that the user has. And I guess the one thing that I want you to be aware of in this case is, and this goes back to this concept of a hard resource boundary, which we're going to get into, versus attribute-based access control, is that it is still on the application to correctly implement the tag permissions. And what that means is, as a general rule, an application that is able to grant or create a session policy or a temporary policy that allows users to read based on an attribute can assign that attribute to anything. So you're still in some sense dependent on the application to do its security correctly. And it's not always that easy to audit from a principal standpoint who has that access at the account level. I wanted to give you a very brief framework to think about how to evaluate the value of third-party attribute-based access control systems. And this is very much implementation dependent. So, in this first one, is the security natively pushed down into the database as a general rule that Immuta or Privacera is protecting, or is it done at the Immuta level? And I'm going to give you an example. So this very much depends on the integration that the Immuta or the Privacera that your third-party ABAC application has with the database that you're protecting. And in the case of something like Databricks or Delta Lake, Immuta actually does the work of pushing that down into the database, and the permissions are done at the database level. There are other cases where you are essentially reliant on the application to function as an intermediary, and this gets into my second bullet. And the applications, in other words, you only get attribute-based access control if you go through the shim that's provided by the Immuta or the Privacera. And so really what I'd like the team to start to think about is, first of all, is this native security that's pushed down into the resource that I'm protecting? Is it done through an intermediary? And am I okay taking this intermediary, if that is the case, as a permanent dependency? If I had to remove this application, what would that look like? And we all know the future that we'd like to live into is that everything is in your private cloud and you can turn off any vendor at will. And that is really the design we tried to go with Quilt, even though our investors don't love it, is that the customer can turn off our service at any time and the data still resides, the data plane and the control plane still resides in your account. So this is just something to think about, is how comfortable are you taking this dependency, and is this a proxy for data security, or is data security actually pushed down to the underlying resource? A quick reminder that the audience can raise their hands if they have any questions, and I'm happy to address those or pop a question in the Q&A. It's to you, Stephen.
Yep. So to quickly summarize ABAC, so it scales for the cases that you optimize for. And this is often one case or dimension. So in the example that we use, it was that resource group dimension. And note that multiple dimensions can close doors for explicitly denying unintended access. And this is due to the limits of the IAM policy language to handle operators like or. So, it is difficult or perhaps impossible to express that we're going to allow access based on a resource group or a team while also denying unintended access. And it gets really complicated, but that's kind of a limit there, or a issue. On the positive side, many AWS resources support tags and tag policy conditions specifically to support ABAC. And AWS is leveraging ABAC heavily in technologies like that is rolling out, including lake formation. But on the downside, it's generally complex, and as Aneesh described, often requires some advanced and usually proprietary policy and tag orchestration. And then something that you may not have thought about, but tag management is now a privileged operation. So if you can if you can add a resource group tag or change the value of that tag, that's now an administration operation, an access control operation. And so you also need to tag consistently across identities and resources that are going to participate in this scheme. And so you have to really think about how data gets in and out of the system, and to make sure you've got the different bases or the different ingress points covered in order to implement your ABAC effectively.
Quick point I wanted to make there. If you think about things like lake formation and glue catalog, which are really designed to solve this problem of granular permissions, they function much like an Immuta or a Privacera, in that in order for, let's say you have a file sitting in S3, a Parquet file, a columnar file, and you want to only grant columnar access or cell access. That access works if and only you come in through either, I don't know if it's the govern table interface or the glue catalog interface. But the key thing there is that there's no real security there is real security. You still have to have permissions to access the underlying resource, but the security that is implemented requires that you come through the front door of a glue catalog or a lake formation in that case. So it's, again, just making this distinction between hard resource-based controls, which we're going to get into key boundaries in just a moment, or resource boundaries in just a moment, and going through an intermediary to provide your security. And in which case it's on you to lock down everything that doesn't involve the intermediary.
Yeah, and that's a good point, that it's important to think about what your dependencies are and how data is both ingested and then accessed, so that you understand like the implications of the rollout and what security gaps there are, if any. So ABAC scales, but is complex to execute. So switching gears a bit, resource boundaries. A resource boundary is an authorization model primarily designed to be applied to resources. And the way you do that is you write resource policies that allow access to intended principals. And there are ways that we can also then deny access to everyone else, including that third party with read-only access. So in resource boundaries, you can also enforce network origin, like the request is coming from a particular VPC or VPC endpoint. And if you're on one great example of a resource boundary is an AWS account. And AWS accounts are great resource boundaries. You, by default, no resources shared outside of an account. And AWS accounts make great resource boundaries, and they work that way and they function that way until you get, 5, 10, etc. teams operating all within that same account. Things get a little messy. So as I mentioned, a resource boundary is a resource policy that controls access to the resource, and it allows certain identities, and it allows certain networks potentially. And the idea is that you put the access control close to the resource being protected. So I call this the least privilege rainbow, and we've got our data store in the center. And even though there's a bunch of identities, a bunch of IAM principals that may have access to pull everything from S3, this resource boundary, whether it's implemented on S3 or KMS, allows only one of those principals access, because the defense is actually placed at the data level. So it's like, okay, great. That sounds awesome, but how do I I have hundreds of buckets. I have more buckets than principals. Well, your secret weapon here is KMS. So encryption is not just for compliance. Encryption is fundamentally about access control. And so only the principal with access to decrypt data, you can control access to data by controlling who can decrypt that data. So consider scoping your data into different data domains and then encrypting the data in each of those domains with its own encryption key. And because AWS data services support encryption at very well, you can create a data domain that spans more than S3. It can cover DynamoDB, it can cover EBS, virtually every AWS service. And the key here is that when an IAM user or role makes a request to S3 get object or DynamoDB get item, there's also an encryption operation that must be allowed, a KMS decrypt. And so if you've encrypted a data domain with, say that project Moonshot, perhaps, or sorry, resource group Moonshot, then you can check this KMS key policy to see who is ultimately allowed to decrypt and read that data. And I describe this in a lot of detail in Effective IAM in the chapter Simplify AWS IAM. But the idea is to transform an access control problem that spans, say, 100 principals or hundreds of S3 buckets and hundreds of other data resources. You can protect access or control access to those data resources in, say, on the order of 10 encryption keys in that same scenario. And the idea being that those key policies explicitly say who is allowed, who is authorized and allowed to use that data, and everyone else is denied. And it can simplify audit. And what I'm showing here is one example of how you might describe that access. And the intent here is to be able to simplify our access control mechanisms so that non-security experts can understand them. And this helps you get scale, because now you don't require a security expert necessarily to create the policy. But say, these are the folks that need to administer the key. These are the folks who need to be able to read what the, and you have a continuous integration and operations principle. Maybe you have team A and team B need to be able to read the data, and team A needs to be able to write the data. And notice that these don't necessarily intersect. Like the administrators actually don't have read or write, although nominally they could perhaps grant themselves access. But if you plug that into a library that is able to generate a strong key policy, like we'll see in a second, this becomes something that you can read and audit from an infrastructure code level. And then like there's a library that's going to generate a key policy that's like 200 lines. And you can find that library for Terraform or CDK. Like we've published, K9 has published that on GitHub. And you can choose to use that directly or lift it and do whatever you want with it. It's open source according to the license. And then in a second, we'll see what that policy, the important bits of that policy and like how that policy operates.
Yeah, so this is the mind-blowing thing about what KMS and resource boundaries allow you to do, and we'll talk about this, is just auditing. So with RBAC and ABAC, it's very difficult. If you're like, oh, who has access to this bucket? Who has access to this object? You're signing yourself up to read hundreds of policies and roles potentially. And the beautiful thing about what Stephen is driving home with KMS is that you just have to look at the key policy. And the principals who are on the key policy, if everyone else is denied, those are always and forever only the principals that can access the data. So that's what's really powerful about resource boundaries with KMS. How many people have seen this checkbox? You can kind of raise your hand. Does anyone remember this when setting up S3 buckets? So when you see this, now drives me to drink now that I've spent time with Stephen, and it's a little bit of security theater. So there's two types of server-side encryption. Everybody wants to check the box for compliance on server-side encryption. There's SSE S3 and SSE KMS. And the difference is in SSE S3, the keys are transparently managed by Amazon. Okay. What does anybody know? What does this actually protect you against? You can throw that in the chat. What does this actually protect you against? It would protect you against a case where a hard drive got stolen for a data center. And that is like, so if somebody rips a hard drive out of a data center and they try to read it, oh crap, it's encrypted and they can't get to your data. That's not the common case. And the real issue with SSE S3 is that anybody who has access to, who can perform get object on that object transparently gets the decrypt. So that is the issue. Whereas with a proper key boundary with something like KMS, you have two factors, if you will, or two layers of security. One is they have to be able to physically access the underlying resource or virtually access the underlying resource. And the second is they have to be able to get the decrypt policy. So again, is this SSE S3 better than nothing? Yes, but it could be a heck of a lot stronger. And that's where SSE KMS comes in. And we're really spending a lot of time kind of retooling Quilt to work first class with resource boundaries. It's a little bit trickier, but again, you get this auditability and an additional layer of security out of it. Stephen, I'm gonna switch back to you. And
Yep.
we've got about 17 minutes left. If we can wrap in 7 and leave time for questions, I think it'd be perfect.
Yep. And importantly, what you said about not being able to actually limit access actually extends to SSE KMS when you're using the default keys for the service. So if you use that default AWS S3 or AWS DynamoDB key from KMS, you'll notice in the console that you can't edit that key policy. So again, anybody who has the ability to call KMS or to actually call S3 get object can read data encrypted with that key. So again, we have some free KMS and S3 policy generators available on GitHub. You can check those out. There'll be links at the end. Let's quickly take a look at what a least privilege resource boundary looks like. Now this is in an RBAC style, and what we have here is that any principal can decrypt or call. They can verify a signature generated by the key as long as their principal ARN matches team A or team B, and you can use likes and other stuff here. The key is, or the important bits here are, this is a core policy condition. It's supported virtually everywhere. The AWS principal ARN is. It allows access to the data domain only for the intended principals. And one of the ways it does that is because if you don't allow access to the account's root user, then identity policies are actually not evaluated for when considering whether a decrypt or when a KMS operation is executed. So let me repeat that. So most the only resource in AWS, in your AWS account, that the root user does not have implicit access to by default are KMS keys, as far as I know. And so one of the neat things you can do here is you can write a KMS or generate a KMS key policy that only allows access to the intended principals. And it may not even be 200 lines at that point. But you can see the full scope of who can access the data in that document. And that policy is applied directly to the resource or within the resource data path. And so it protects data from unintended access, because you wouldn't accidentally take that third-party service and jam it and explicitly allow into your moonshot data domain. So to wrap resource boundaries, it's a way to simplify access control and enable non-security experts to use it. It scales to all AWS data services, and it makes an easy to audit control point, and that you can use to prevent unintended access. And because we're talking about adopting a key at a time, or generating or provisioning a key at a time, you can adopt incrementally. On the downside, you will need a key policy generator, and to generate that policy correctly, and you may need to use bucket keys to control KMS costs. So I see a question. Yes. How is this different from tag-based access control? So that's a great question. Thank you for asking it. And that's why this right here is an RBAC style policy. You could also implement this key policy in ABAC style. So the positioning of RBAC and ABAC versus resource boundaries is a little it's a little messy. What the real positioning between these models is, perhaps you have models that are skewed towards think about how you're going to manage your access and identify what models you're going to use to control and grant access on the principal side, and what model you're going to use to control access on the resource side. And we'll actually get to that in a bit, in a little more cleanly said. But the takeaway is that resource boundaries can scale, but they require policy automation. So to wrap, scaling IAM requires trade-offs. So when you think about these models, think about how they're going to work in your environment, and which attributes you need. Do you need scalability of principal access control, resource access control? Where do I need to pick up and invest in usability? Which portions of my design, where do I need to have a lot of flexibility, or understand when you pick a dimension to scale upon in ABAC, the implications of trying to add a second dimension. So, and go ahead and analyze all your trade-offs and combine approaches is my recommendation. And that's how to simplify and scale. Choose one of RBAC or ABAC to allow principals access. Use resource boundaries to deny unintended resource access. And ultimately, really simplify access management intentionally. Choose, analyze how it is that your environment works or wants to work, and then pick the best parts of each model and try to combine them into something that works for your organization. And then there is another slide here with links. If you didn't recognize it, the little furry things, those are called tribbles. But right now, why don't we just take some questions?
Let's call it there. Hope you enjoyed it. I certainly learned a lot. I want to thank Stephen for joining us, and I think both as Quilt and K9 will be seeing you in the near future. Thank you. It was great meeting you all.